Welcome back to the 9th lesson in our beginner series on learning Python. In this lesson, you will learn to use relational operators to create Boolean expressions. So in this lesson, we'll recap what an expression is. We'll look at what relational operators are and how they can be used to create expressions. We'll look at truth values and Boolean expressions, and we'll look at how we can use relational operators in the shell. So just to recap, we've already learned that Python expressions express values. They represent values. The computer interprets an expression. We also say it evaluates the expression. And the result of the expressions that we've used so far are of 3 data types: integer, float, or string data types. If you're not clear about any of this, go back and look at some earlier lessons. So you've already learned about creating expressions using arithmetic operators. Well, here's a different type of operator. It's called a relational operator. And a relational operator represents the relationship between 2 values. In other words, it compares 2 values. And the result of that expression is either true or false. So the main relational operators are shown in this table. Double equal sign is used, for example, to show that 2 values have the same value. So an expression with the double equal sign will be true if the values on either side of that relational operator are equal in value. So let's have a look at some examples, and you can try these out in the shell. So in this example here, 3 times 3, the expression 3 times 3, is compared to the expression 9. And of course that expression is true because we're comparing 2 values that are the same. So the computer will evaluate 3 times 3 and it will evaluate 9. They both come to the same value, 9. And so the 2 values are equal and we get the value true. Whereas 3 times 3 is bigger than 10 is false, and so on. So if you look through those, you can see that we can compare the variable x, and we can have comparisons that are true or are not true. It's worth noting here that we can use the single equal sign to assign a value to a variable, x equals 2 * 5, and we can use the double equal sign to compare a variable and a value. So double equals and equals mean very different things in Python. There are some comparisons that we're not allowed to do. So we can compare 9 with 9.0. That 9 is an integer, 9.0 is a float data type, but they both have the same number value, so the computer will say it's true that they're the same. If you compare 9, the integer 9, with the string 9 in quote marks, the computer is happy to make that comparison and it will say false. They're not, they don't have the same value. It will allow you to compare larger than and smaller than between integers and floats. So 9.9 is bigger than 9, that's true. But it won't let us say that a number is bigger or smaller than a string. And look at the bottom line of the error message here. Greater than is not supported between an instance of float and an instance of string. You can't compare. You can't say that a number is bigger than a character string. We can compare strings with each other and have a quick look here. So A is equal to A is pretty obvious. Uppercase A is not equivalent to lowercase a. The computer thinks those are different strings, which of course they are. And when it's doing greater than or smaller than, it will use alphabetical order. So ABC comes before X, Y, Z. So greater than or lesser than represents alphabetical order. A string later in the alphabet will count as bigger than a string earlier in the alphabet. It will also take capital uppercase letters as smaller than lowercase letters. So uppercase A is smaller than lowercase a, according to the computer. And cat with a capital C is smaller than cat with a small c. So that's because of ASCII codes. The ASCII codes for uppercase characters are smaller numbers. And here's one final and I think really useful relational operator, and that's the in operator. And it will tell you if one small string is in another larger string. So A is in cat, but A is not in lion. AM is in team, but me is not in team. So that's also, you can have a play about with all of these operators in the Python shell. Or if you're writing a program and you suddenly want to check a comparison, go to the shell and type in the expression, and the computer will immediately evaluate it for you and tell you whether it's true or false. So we've learned 4 different data types now: integer, float and string, which you already know, and Boolean. So some expressions evaluate to true or false, and that is a special kind of data type called Boolean. It's named after George Boole, who invented a lot of our modern logic. So the Boolean value true is shown in gold letters. It's a Python keyword, and it's different from the string true in quotes. It's not actually the word true, it's the idea of something being true. So I've used the type function here. So the type, the data type of the gold word true is the Boolean data type. The data type of the word true in quotes is a string. They're different things. We can convert other data types to Boolean. So any number or any text or any fraction, minus, plus, any length of string, these all count as true. So a number, a string, a piece of data, it always counts as true. The only exception is the number 0 or a string that has no characters in it at all, what we call an empty string, just quote marks next to each other. And if we turn those into Boolean expressions, the computer counts those as false. You can assign the true false value to a variable, or you can just print it out. So in this first command here, I've told the computer to print out the value of whether the word eat is in the longer text string none eaten. That's obviously true, so the computer's just printed out the word true. No quote marks noticed, just the word true. And here I've is the word art in the string none eaten. I've assigned that expression, the value of that expression, to a variable called test, and then when I print out the value of the variable test, we see that it's been holding the value false. So true and false are the values of those expressions. So here are some extra challenges for you to explore Boolean expressions and relational operators. I'm challenging you to find out whether some of the non-letter characters, such as the symbols, the digits, punctuation marks, come before or after each other, and do they come before or after the letters of the alphabet? If you find an ASCII table online, that will help you. Write a program which takes two inputs and outputs true if they are identical. And then write a program where you input a letter and a word and it tells you if the letter is in the word. Okay, so have a go at those, and if you can get those all working, then that you can be confident that you understand relational operators and Boolean expressions. See you in the next lesson.